Hello and welcome to our physical sciences session. My name is Themba Ncube. Today we are focusing our attention on solving circuit problems. So we're going to take a discussion on, the approach to responding to typical examination questions, and also, share some of the strategies, that one may actually make use of in terms of, responding to questions. We'll also try and, zoom into the multiple choice and some of the dynamics, things that one has to look out for in as far as the multiple choice is concerned, right? We have done by this time, the different aspects of, circuits, in terms of power, the Ohm's law, and it all comes together if we have the necessary understanding so that we can be able to apply the knowledge that we have gained in responding to, problems. Okay, right. Okay, some of the concepts that I would look into or apply in as far as problem solving have to do with understanding the Ohm's law, which talks about the relationship that exists between current as well as voltage at constant temperature. But also remember that this is in the context of electric circuits, which can either be a parallel circuit or a series circuit. Now, if you talk of a parallel circuit, this has to do with current dividers. Okay, the current dividers, very important. Understanding, as well as potential dividers in as far as the series circuit is concerned. Okay, so these are the main ideas. So if we are to apply this knowledge, this has to come to the fore. But also remember, we need to understand what power involves in terms of energy conversion per unit time, and power has implications on the cost of electricity that we use in our homes. Okay, right. These are some of the concepts that we dealt with in one at a time, but at some point we need to create these very important links between these concepts so that we show some understanding. Let's focus our attention now on the formula sheet. So the data sheet, we are saying it's going to be provided to you, during the assessment time or when you write, your tests, your exams. You need not to memorize all the formula because there's a whole lot of them. Okay, so just understand that, okay, a particular question has to do with a certain concept, and these are the relevant formulae, the mathematical equations that you'd want to make use of as part of problem solving. So it's important to be able to identify the formula, copy it as it is given, okay, do the necessary conversions if that's the case, before doing the substitution, and then do the calculation using a scientific calculator. Make sure that, again, the SI unit, which is correct, is attached to that value that you are calculating. And in some cases, there is a need that you interpret your answer, because we need to put, the science behind the numbers. And beyond that, we have a multiple choice scenario. Okay, there's a lot of perceptions in as far as the multiple choice is concerned. But what is important about multiple choice is that we need to allocate, a decent amount of time, reasonable time, to respond to those questions, because not all the questions require the same effort, in terms of arriving at the correct answer. Never mind, we are given, 4, possible options, and then now we need to identify the 2 distractors so that we get that out of the way. Then you'll be left with 2 options. In most cases, you choose the correct answer, thereby, enhancing your chances of actually getting it correctly. Right. Now, so the data sheet is a very important tool in terms of the conceptual understanding. So you can immediately tell that this formula has to do with current, which from this we can say, okay, current is the rate, of flow of charge. Okay, is the rate of flow of charge. Okay, so we are simply reading it off mathematically. That's our Ohm's law there. Okay. So we need to be familiar with all this. We know this is the formula that we use to calculate total resistance in a series circuit, okay, while the other one is for a parallel circuit, all right? Okay, and then the issue with energy, okay, which you would have discussed in as far as, power is concerned. This has got to do with energy. You know, work is energy, energy is work. When work is done, energy is converted from one form to the other. And then these are the variations in terms of the power formulae, okay? So you'd identify the correct formula based on what you are given, okay? Now we look at a typical multiple choice problem which reads as follows. Which one of the following is equivalent to 1 volt? So the idea here is that, you know, we're looking at the understanding of the quantities in terms of the SI units, okay? So let's locate the SI unit volt in terms of its quantity. This has to do with potential difference. This has to do with potential difference, okay? So when we talk of potential difference, we are talking of voltage, okay? And what do we know? We know that V is equals to W over Q. So this is actually, what are we saying? We are saying that voltage across a device is the work done per coulomb of charge. So the work is measured in terms of energy in joules, while charge is in coulombs, okay? So we can immediately say that a volt is equals to 1 joule per coulomb of charge. So we are able to immediately identify the correct option. But then the other option, joule second, it's something else. This is like energy multiplied by time, of which we don't have such. And then joule per second, maybe this is what we call the watt, which has to do with power. So this is out, that is out, and then B and D are actually saying the same thing, because 1 watt is equals to 1 joule per second, right? So that's how you would actually approach the question. And then we've got another one which says, in the circuit below, a battery with an EMF E. So we are given the EMF, okay, which is the maximum energy that can be provided by the source, which is the battery in this case, for every coulomb of charge. And then we're told that the battery has got negligible resistance. So when the resistance in a battery is negligible, what does it mean? It means the EMF, okay, is actually equals to the terminal potential difference, okay? Okay, what does that mean? Because the battery has negligible, or, you know, a very small resistance that we can ignore, it means the maximum energy that this battery can provide is actually equal to the terminal potential difference, which goes to the external circuit, okay? Now, these two are connected to 2 resistors in parallel, okay? The resistance of one resistor is double the resistance of the other. This is a very useful piece of information, okay? What are we saying here? We are saying that the 2 resistors, the other one is R, the other one is 2R, okay? So if that's the case, it means one resistor is actually double the other one in terms of resistance. And then the question says, what are the ammeter readings and voltmeter readings in this circuit? Okay, we are told that the current that passes through the ammeter is I, right? Now, the I, which is the total current, which is the current that passes through 2R, because this voltmeter will actually measure I, okay? Is it fine? Because you think of it in terms of, okay, when the current gets to that point, it is split, the other one goes to 2R, the other one goes to R. And then the question says, what are the ammeter and voltmeter readings? Okay, let's understand something, okay? If I goes through, current I goes through that ammeter for 2R, how does the current that go through R compare to that goes through 2R, okay? Remember, from the Ohm's law, we know that current is equals to V over R, okay? So what else do we know? We know that V across R, okay, is equals to V across 2R. Why? Because these 2 resistors are connected in parallel. So V across 2R is equals to V across R, okay, because it's a parallel circuit. Now, if the resistance of 2R is double that of R, what does it mean? It means R will receive more current than the current that goes through 2R, okay, because 2R is double R, okay? That's another way of actually saying it. So the current that goes through 2R, okay, is equals to I, right? and then the current that will go through R, it must actually be double the current that goes through 2R, because R is less resistance than, actually is less resistance than 2R, okay? Now, in terms of E, we know that the potential difference, which goes, the potential difference across 2R is equals to R, because the two resistors are in parallel. So obviously, if it says double, it means option A is out. Why? Because it says double while E remains constant. Okay, so that is also out. So we are left with option B and C, right? And E and D rather. Okay. Now let's check. If the current that goes through I, 2R is I, it means the current for R must be double that. Okay. So if the ratio, total ratio is 3, then the current for the ammeter reading 2R should be actually a third of that, because the ratio is 1:2, okay? It's actually 2:1 if we say 2R is to R. So it's 2:1. So the one that goes through 2R will be 1/3 of the total current in the circuit, all right? Now, which means our solution in this case becomes option B. Okay, this is actually the current that goes through, this is the current that goes through R, okay? Right, and then the last one, multiple choice for the segment. In the circuit alongside, the power dissipated by the 3 ohm resistor is P, okay? So the power here for the 3 ohm resistor is P, right? And the power dissipated by the 6 ohm resistor is what we want to understand. Okay, what do we know about these two resistors? We know that the voltage across 6 ohms, okay, let's call this V2, okay, is equals to the voltage across 3 ohms. Why? Okay, because we're saying V across 3 ohm is equals to V across 6 ohm, okay. Why? Because it's a parallel circuit. But the current that goes through 3 ohms is actually double the current that goes past 3 ohms. Why? Because this parallel circuit is actually a current divider. So the smaller the current for the same voltage, you know, the smaller the resistance for the same voltage, the greater the current. So the formula for power says P is equals to I squared R, okay? So if it's I squared R, if more current goes through 3 ohms than the 6 ohms, or even if we look at it in terms of P is equals to V squared over R, okay? Now you'd realize that the V1 is equals to V2, okay? Based on that parallel combination of resistors. So the one that has got the smallest resistance will have the greatest power for the same voltage. So if the 3 ohm resistor is P, it means for 6 ohms, it should be half that, because the ratio or the proportion of these two resistors is 1:2. So it means the 6 ohm resistor will dissipate a power which is actually half, which takes us to exactly that. So you may realize that not all multiple choice questions ask the same level of, you know, understanding. In some cases, you have to apply a number of concepts like we've done with the previous one. So you need to take that into account and also try and best manage the time that you have, which you allocate for your multiple choice problems. When we come back after the short break, we'll look at, you know, the typical structured or long questions which you'd normally find in your section B. Let's take a short break for now.